Today, there are thousands of nanotechnology products on the market. Many of them are invisible. And probably the biggest market in the world today is for nanoparticles. There are various types of nanoparticles used for different purposes. The chances are you have nanoparticles on you at the moment, but you don't even know it. And so that's going to be our focus, nanoparticles. Now, when we say nanoparticles, we think immediately of today. But in actual fact, let's start the story way back in Roman times. Okay, in this part, I'd like to discuss nanoparticles. And like nanotechnology, nanoparticles are defined as particles which have diameters between, say, 1 and 100 nanometers. Nanoparticles turn out to be probably one of the biggest areas of business in terms of commercial products on the market today. And you may think nanoparticles are very new. You've heard of, like Crichton's book, Prey, where, nanoparticles get loose and, they float around like mist. But actually, nanoparticles have existed for a long time. It's just that people didn't know what they were. One of the examples is this cup, which is from the British Museum, which is around about 400 BC. And when you look at this cup in the daylight, it appears to be green. But if you illuminate it from inside, it's red. And that coloration is due to the fact that the Romans had found a way to introduce, for the dye, nano-sized gold particles. So nano-sized gold particles do not look like gold, the golden color. Rather, they have very specific properties. And this is one example of nanotechnology, if you like, in Roman times. In the 15th and 16th century, pottery glazes in Italy, this is in Umbria, contained copper and silver nanoparticles. And this beautiful coloration here is not due to chemical type glazes, it's due to these nanoparticles. And you also find this type of effect in stained glass. So depending on the form, the type of nanoparticle and its size, you can generate a whole host of colors. And it gives the stained glass this marvelous quality that can't be achieved using regular pigments. So what can nanoparticles do in terms of when you fiddle around with them compared with the nanoscale? So let's look at some of the properties. If we take an opaque material, like for instance zinc oxide, white paste that's used as sunscreen, and you downsize it to the nanoscale, you make nanoscale particles of zinc oxide, it will become transparent. So you can apply it to your skin, it still has the same sunscreen effect, but it's no longer visible. You can take an inert material like gold. Gold doesn't react chemically in any way usually. And if you put it onto the nanoscale, it can become a catalyst. For instance, a catalytic converter in a car for converting CO to CO2. We all have catalytic converters in our cars, or most of us do. You can take a stable material, and if you put it on the nanoscale, you can make it combustible. You can make new forms of explosives, unfortunately, using that type of technology. And then you can take something that would normally be a solid, and on the nanoscale, these nanoparticles would behave like liquids. You can take insulators, and on the nanoscale, they would become conductors, or you can take conductors on the nanoscale and become insulators. So by changing the size of the nanoparticle, you can give the particle all sorts of different properties that you would never expect on the large scale. And that has great benefits, potentially, in technology, but of course it also has risks, because the toxicology of a particle on the macroscopic scale may differ radically when you turn it into, for instance, a nanoparticle or a nanopowder. Today, the most sold nanoparticles, and you'll find them probably in your sportswear, in socks, in underpants, you find them all over the place, are silver nanoparticles. And they have an antimicrobial effect. So you can wear the socks for a long time, they never smell. You can use your sports gear and you don't have a buildup of bacteria or microbes. And effectively, these particles can go into the bacteria and they can destroy them. They're used in many other applications, like some stay fresh bags, food packaging, and so on. They can keep the food lasting a long time. Samsung have introduced refrigerators that contain silver nanoparticles, and the chances are, I would guess, that you've got silver nanoparticles somewhere on your body, and you may be kind of surprised by that, but that is the way we have been working. And to give you an indication that that's true, recently they discovered silver sulfide nanoparticles in sewage sludge. Now, silver nanoparticles, or silver in general, will typically react with sulfur. For instance, if you put a silver spoon in an egg, it will turn black. That's the formation of silver sulfide. But these silver sulfide nanoparticles in the sewage are rather disturbing. We already know in sewage there are many, many pharmaceutical products, birth control pills and the likes. And that goes into the ocean often, and it can influence the development of fish. That's been noted in Santa Monica in the bay. We don't exactly know what these silver sulfide nanoparticles can do, but we know because of their antimicrobial effect in the silver state that they do major things in biological systems. Other ways people have used nanostructures or nanoparticles has been in terms of biomimicry. So one of the interesting things about the gecko is able to walk up and down walls. It's able to support its weight. Just a square centimeter of gecko feet could support the whole weight of a gecko. So people are trying to make new forms of adhesive in which they replicate the structure of the gecko feet. And again, it's a nanostructure. And they have developed actually reusable tape that's based on that. So this is a picture here of different magnifications of the gecko feet. And you can see from the bottom image here, very fine nanostructures. And these fine nanostructures give the gecko feet this amazing ability to adhere to walls. We in the science labs haven't been able to replicate this completely, but if we could replicate this 100% with the efficiency of, the gecko, in principle, we should be able to climb walls ourselves. Another effect when you make particles on the nanoscale is that you can change properties. And the lotus leaf uses this effect. You see these droplets of water on the lotus leaf, and they appear to be spherical. That's because the water does not like the lotus leaf surface. Now, that's not due to the chemistry. This phenomena is called hydrophobicity. It's phobic for water, is due to the structure on the nanoscale of the lotus leaf. So let's look at that, and you see these like particulate-like bumps that have even more nanostructure on them. What they essentially do is they change the wetting of the water on the surface, and it becomes non-wetting, hence the particles are spherical. So water would just run off the lotus leaf. It does not stick. And the lotus leaf is able to keep clean and uncontaminated using this type of nanostructured surface. This has inspired many companies to make self-cleaning fabrics. This is Minicor. There are many other ones on the market. Nanotech, for instance. And Docker's jeans, for instance, had such coatings so that you could throw ketchup on it, it would just slide off. It's completely, it still breathes, but it doesn't get dirty. Other places where you'll find these self-cleaning fabrics are increasingly in furniture, upholstery, and so on. Another type of self-cleaning effect occurs in glass. Almost every glass manufacturer in the world today, in addition to making conventional glass, makes self-cleaning glass. And the self-cleaning glass contains nanoparticles of titanium dioxide. And what happens is essentially that as dirt sticks to the glass, then sunlight reacts with the nanoparticles, and those nanoparticles then photocatalytically, it's called, they break down, for instance, the grease and oil on the surface into smaller parts. And if it then rains or you just throw water on that glass, all those particles will come off because the surface is also hydrophobic. It does not like water. So you can see in this picture, the conventional glass, the water's sticking, and the self-cleaning glass, the water just runs off. And this is found in products like, for instance, I think BMW have self-cleaning glass as an option. And eventually we will find self-cleaning glass everywhere. In addition, people have also made self-cleaning concrete. So we can save a lot of energy in terms of cleaning things by using self-cleaning surfaces using titanium dioxide. If you've been in Japan, there's a bullet train, very fast train that goes up to 300 kilometers an hour. They have used also a nanotechnology, self-cleaning coatings on the Shinkansen. And the advantage of that is they use less energy and they don't need to clean the train so often. Another place you'll find nanoparticles are in things like plastic beer bottles or in tennis balls, where a material called nanoclay is used. The nanoclay are these sheets of material, only several nanometers thick, that are put into the plastic or into the surface of the tennis ball. And the reason for that is to reduce gas permeation so that the tennis ball remains inflated for much longer period than regular. Likewise, with the beer bottle, the carbonation remains in the bottle and cannot escape. So today you are actually exposed to nanotechnology in many ways, even though you don't know because you can't see them.